Hey everybody! So today's video is going to be just a little bit different. We're going to be doing a LeetCode coding exercise. I wanted to do this for a couple of reasons. First, programming exercises are just really cool and a lot of fun. And second, I think this is a great way that we can apply and solidify any of the Java knowledge that you've been learning on your own, or in my YouTube videos, or in my Java course, which, as you know, you can find down in the description below, so go check it out. Okay, so let's get right to it. We're going to be starting with the very first LeetCode problem called Two Sum. What I want to show in this video is the initial solution that you would probably come up with for this problem and how to do it. But after that, we're going to talk about a much faster solution that uses a different technique and a way of coming up with the answer to our problem. And we'll see exactly how much faster it is and talk about why. So the description of our problem is: given an array of integers called nums and an integer called target, we're supposed to return the indices of the two numbers in that array such that they add up to the given target. And so literally over here in the code, we are going to implement this toSum method, and then as parameters to that method, we're going to receive an int array called nums and an int called target. And we're just supposed to find the two ints inside this array that add up to the target. Now there's a couple of restrictions and assumptions that they give us here. We can assume that each input will have exactly one solution. So that means we should always be able to actually find a solution. There'll never be an instance where we don't have two numbers in this array that add up to the target, but also that we won't have two separate solutions. And there's a rule that we can't use the exact same element in the array twice. Now our solution here will be returned as this int array return type. So once we find the indices of the two numbers in our array that add up to the target, we're supposed to return an array containing those two indices. Remember, not the two numbers that add up to the target, but the indices, or the indexes of those two numbers in the array. So they provide an example here of this being the nums array that's passed in. So you have 2, 7, 11, and 15 with a target of 9. So the goal of our code is to find the two numbers, or the indexes, the indices of the two numbers in this array that add up to 9. So of course we can see that in this array, 2 plus 7 equals 9. So those are the two numbers that add up to 9, but our output should be 0 and 1, because those are the indices of 2 and 7 in our array. 2 is at the index 0, it's the 0th, the first element in the array, and 7 is at position 1 in our array. So we return an array of 0 and 1. Now I like coding in IntelliJ a lot more than I like coding in a browser. So I'm going to go ahead and copy this over to IntelliJ so that we can do all our coding and problem solving here. And then once we have a solution, we're going to submit it. Just go ahead and paste it into the browser and submit it there. I'm also going to go ahead and paste in one example problem just so we can have something to visualize and talk about the way that we're coding the solution. So probably the most intuitive way that you might come up with a solution, the first one that I came up with, is just a simple nested for loop. So first, in the outer for loop, we would just loop through all the elements in our nums array, and we can just do it like this. So for int I equals 0, we'll go while I is less than nums.length, and then increment I each time with I++. So here in our example problem, our input array is 5, 2, and 4, and our target number is 6. So this for loop that we've just made would start at the 0th element of this input array, and then just loop one by one through each element in the array until it reaches the end. But now inside this for loop, we want to have a nested for loop. So here's what I think we can do. We start with our I at 0, the 0th index of our array, which is 5. So what we can do is loop through each number that's after that 5 in our array, and then add it to 5 and see if we get the target number. So first we could say, okay, let's take 5 plus 2. Does that equal 6? No, it does not. So 5 plus 2 doesn't work. Next, we try 5 plus 4. Does 5 plus 4 equal 6? No. Now 4 is the last number of our array, and so that inner loop will end. And then we will increment in the outer loop. So instead of starting with 5 in this next iteration of our loop, we will start with 2. Does 2 plus 4 equal 6? Yes, it does. So we have reached our solution. We know there is only exactly one solution. So now that we have that solution, remember that we have to return the indices of those two numbers, not those numbers themselves. So we won't return 2 and 4, we'll actually return 1 and 2. So with that said, let's go ahead and implement our inner for loop here. Now usually in an inner for loop, instead of using I, you just use int j. Now what do we want to initialize j to here? We don't want to initialize it to 0 like we did for I. And that's because we don't want to start by adding the first number to itself. And we're not allowed to use the same element twice in our solution. So instead of starting with the 0th element in the array like our outer loop does, let's start with whatever the current index that we're looking at in our outer loop plus 1. So for example, in the outer loop, if we're currently looking at the value here at index 0, in our inner loop, we want to be looking at the number at index 1. So we can do that by just saying I plus 1. However, the next part is pretty much the same. We do want to keep iterating while j is less than nums.length. So we're starting at one number past the number that we're looking at, but then comparing that first number to every other element in the array all the way until the end. And then to iterate in our inner for loop, we do the same thing with just j++. Okay, so now inside our inner for loop, we have the two values that we want to add up to see if they equal our target. So all we have to do at this point is just add the two numbers that we're looking at together, check to see if it equals our target, and if so, return the indices of those two numbers. So that's a pretty simple if condition. So if the value at index I plus the value at index j equals our target number, then we know that we have the solution that we're looking for, and we just need to now return those indices. And we want to return them as a new int array. So we just say return new int array, and the two elements of that int array are going to be our two indices that we're looking at. So that would just be I and j. So that's pretty much the algorithm. Now you might notice that we are getting an error over here that we are missing a return statement, and that's because it's technically possible that we would get to the end of our method here where we say that we're going to return an int array, and if we don't happen to find a solution, it won't return anything, so we have to return something. Now according to the rules of this LeetCode problem, it's always going to have exactly one solution, so in this situation it doesn't matter a whole lot what we return, it just has to be some int array. So what we can do if we want is just return this nums array that's passed in. So let's go ahead and copy and paste our code back over here into LeetCode and submit it and see what happens. Okay, here we go. And okay, so it succeeded. But the runtime was 140 milliseconds, which is faster than just about 7% of all the Java submissions for this problem. So this isn't a very fast or efficient solution. Now sometimes with LeetCode you can submit it another time or two and see if it just happens to run faster in subsequent calls. Yeah, so in this case it took 113 milliseconds, which is now about 14%. But it's still not very good. There's still a lot of people who are submitting a faster solution than this. So let's see if we can come up with a better way of doing this that's faster. So first of all, the reason that this solution is so slow is because it has a big O time complexity of n squared. So what exactly do I mean by that? Well, anytime you have a nested for loop in your algorithm, where both the outer for loop and the inner for loop loop over all the items in your array, most of the time that's going to give you a quadratic time complexity. So that which means a big O of n squared. Now for small data sets like we have in the problem examples that we've been looking at, that time doesn't really matter. But once you have thousands or tens of thousands or millions of objects in the array that you're supposed to do your calculation on, that kind of time complexity starts to really matter. So even though the operation that it's doing on those two numbers is simple, it's just adding them up and then comparing them to another number, the problem is that it's having to do that comparison hundreds of thousands, millions, or billions of times. So what if we could come up with a solution where instead of doing that, we could just loop through our array one time and get rid of our nested for loop? And to do that, we have to come up with a little bit more clever of a solution. So let's hop back over to IntelliJ and try and work this out. So here's the idea for this faster solution. We are going to use a map. Specifically, we're going to be using a hash map. Now, if you want a good refresher on maps or hash maps generally, go and check out my video on that. But as a quick reminder, all a map is just a collection of key value pairs. So when you add a thing to the map, you add some certain key, and then you also add some value that it maps to. And then later what you can do is give the map some certain key, and it will retrieve the value that it has stored for that key. And the way that the hash map does that lookup, it's super fast. It's in what's called constant time. So what we're going to do is we're going to loop through our array one time. And each iteration through that loop, we're going to add something to our map. So as we're iterating through our array, for each number that we look at, what we're actually going to store is the number that we would have to add to this number to get to our target. That will be the key that we add to our map. So for example, let's say we're looping through our array and we start at index 0, which is the number 5. We say, okay, what would we have to add to 5 in order to get our target 6? Of course, it's 1. 1 in this case is known mathematically as the complement, which doesn't matter a whole lot, but it gives us a good name to talk about it. So that complement will be stored as the key that we're going to add to our hash map. And then the value we're going to be storing at that key is the index of that number that we were looking at. So as we're looking at the number 5, we know that 1 is the complement. 5 plus 1 gives us our target 6. And the index of this first number that we're looking at is just 0. So we would add to our map a key of 1, which maps to a value of 0. But here's the really crucial part to this algorithm. Why is this information so useful? Well, the reason is now, as we keep iterating through this array, we know that if we encounter the number 1 anywhere along this array, we know that we can add that to this number to get our target number. So that might take just a minute to sink in, but that's the most important part of this algorithm. So basically what we're going to do is loop through each number in our array. And first, we're going to check whether that number already exists as a key in our map. And if it does, then we know that we've found our match. And in that case, we just need to return the indices of those two numbers. So one of them is the index of the current number that we're looping through, and then the index of the other number that we need to return is just going to be stored at that location in our map. So let's walk through how the algorithm is going to work for this set of numbers. So we just have one for loop that's iterating through this array. So first we're looking at the number 5. Now what would we have to add to 5 to get to 6? 1. And we can calculate that by just taking our target minus the current number that we're looking at. Of course, 5 plus 1 equals 6. So in this case, 1 is our complement, and this number is index 0 in our array. So we would add an entry to our map, which has a key of 1, the complement, and a value of 0, which is the index of that number. So then we move on to the next element in the array, 2. First, actually, what we do is check to see if 2 already exists as a key in our map. So in this case, the number 2 doesn't yet exist in our map. So then we say, okay, what number would we have to add to 2 to get to 6, which is 4. So 4 is our complement here. So we add that 4 as a key onto our map. And the value that we associate with that key is the index of the number that we were looking at, which here is 1. So next we move on to the next element in the array, which is 4. Now first we ask, okay, does 4 exist as a key in our map? Yes, it does, right here. So now that we found that, we know that we have a match. We know the indexes of the two numbers that add up to our target. But how do we know that? Well, right now in our loop, we're looking at the number 4, right? So what we've done is gone and look up in our current existing hash map whether we have the number 4 as a key, and we do. And the value associated with that key is 1. Now remember, this index is where we can find a number that we have to add 4 to get to 6. And now that we have a 4, we know that we can add that to the number at this index to get our target. So in this case, our answer is first the index of the number we're looking at, which is 0, 1, 2, index 2, and the index that we find when we look up that number in the map. So we look up 4 as the key in our map, and we get the index 1. So we return 2 and 1. Now I promise if you give it a little bit of time, maybe rewatch that last section a couple of times, it'll all sink in and make sense. So with that, let's go ahead and actually implement that solution. So first, let's go ahead and get rid of our inner for loop here, because we know that we don't want to use any nested for loops. But our outer for loop is still going to do the same thing. We're going to loop through all the numbers in our array. But before this for loop, we want to actually create the hash map that we're going to be storing all of that information in. So to create our map, we can just say map. Now we have to tell Java what types that we want to use for our keys and values in our map. In this map, the keys are just going to be those complements that we calculate. So those can just be integers. And the values associated with those keys are just going to be the indices of those complements, which are also just integers. One thing to keep in mind is that you might try to use ints here instead of integers, but you're not allowed to use primitive types here. So you have to use their wrapper classes. So instead of int, just make sure you use integer. Now we need a name for this map variable. So because it's going to contain the complements that we store and the indices of those complements, we'll just call it complements. And then we need to initialize that as a new hash map. We just have to open and close the angle brackets here, open and close parentheses, and there we go. Okay, so now inside our for loop, for every number that we're looking at as we loop through our array, we first want to see if that number already exists as a key in our complements map. So to see if the value that we're looking at already exists in that map or not, we can just call a method on that map called .get. And so here, as the parameter to this get call, we want to pass in the number in the array that we're currently looking at. So that's not going to be I, because I is the index of the current number that we're looking at. The number at that index is nums of I. So if the number that we're looking at exists as a key in this array, this will retrieve it for us. And if it doesn't exist, it will just return null. So what we can do is store that value in a variable. So integer, let's just call it complement, and then we'll set that equal to the result of this call. But actually looking at this, because when we get the value that's stored at this key in the array, the actual value that it's giving us is the index of the number that has that complement and not the complement itself. So a better name for this might be a complement index. So now if this complement index is not null, we know that we've found a match. So we can just say if that complement index is not equal to null, then we know that we have a match and we just need to return our two indices. So we can just say return a new int array. Now what are the two indices that we want to return? So the first index is just I, the index of the number that we're currently looping through in our array. Now next is the index of the number that we can add to that number to get our target, which we know is stored at the complement index. Okay, so we know that if we find a hit in our map, then we have a match and we can just return the indices. But if we don't, then we have to calculate the complement and add it to our map. So to add an element to a map, you just call that map, so complements.put. Now this put method takes two parameters, the key as the first parameter and the value as the second parameter. Now in this case, we said that for the key, we wanted it to be the complement of the number that we're looking at, which is the number that we have to add to that number to get our target. And we can do that just with simple subtraction. So we can take our target minus the number that we're currently looking at in our array, which is just nums of I. And then for our second parameter, for the value that we want to store at that key, remember we just want it to be the index that we're currently at. So that's just I. Okay, so I think that should just about do it. So I'm going to go ahead and copy this and then go back over to LeetCode and paste it in. And we'll go ahead and submit it and see how it goes. Okay, so it also succeeded, but way, way faster than our last solution, just 2 milliseconds. And so it says here that's faster than 94.58% of Java submissions for this problem. So that's way, way faster. That's like more than 50 times faster than our previous solution. It's an insane difference. And the reason for that drastic difference is now we're only having to loop through our array exactly one time. So now instead of having a time complexity of big O of n squared, it's just big O of n, which we call a linear time complexity. One thing to note about our newer solution, though, is that it does, at least theoretically, take up just a little bit more space, a little bit more memory. And that's because it has to create and manage this hash map. So for example, in our last few runs, so the first run of our initial algorithm was 45.1 megabytes and then 45 megabytes. And then the memory taken up by our current solution is now 46.2 megabytes. And there could be a lot of variance even within different runs here on LeetCode. So if I submit it again, I might get a different runtime in memory. Let's see. So yeah, this time we get a 3 millisecond runtime and 46 megabytes of memory. So it's not really that big of a difference in memory, but it is something to note. There could be some algorithms that you can make a whole lot faster with a lot more memory, and then you might have to weigh the pros and cons of using that much memory. But in this case, it's so dramatically faster, it's not even close, and the amount of memory taken up is just negligibly different. So it doesn't even matter. This is just a way better solution. Now, if you're kind of newer to Java or newer to programming in general, you might have thought, man, I never would have thought of that kind of a solution. Even if, maybe I know what a map is and how it works, but I never would have thought to use a map to do this kind of lookup to avoid having to do all these calculations. Now, I'll just tell you, that's totally okay. The more of these kinds of problems that you do and you figure out the solutions for, or even you watch a video or you look up the solution, you kind of learn, oh, that's a technique I don't really think I would have thought about. And then you just stash that away in your head, and your arsenal of potential tools for figuring out clever solutions for these kinds of problems just grows and grows. So I want to encourage you to just keep at it. Keep creating things that you enjoy making, and if you like, try these kinds of programming challenges as well. The more you do them, the better you're going to get at them. Now, I'm really curious what all of you think about videos like this. Would you like to see more programming challenges? Do you like doing things like LeetCode, or do you have suggestions for others? I would like to be able to come up with some kind of content that I can deliver to you more regularly, and something like a coding challenge I think enables me to do that. But if you have ideas for other things you'd like to see me do on a more regular basis, I would love to hear them. So just let me know down in the comments what you think, or if you have a way to make this even faster, let me know down in the comments too. I would love to see that. So as always, of course, like, subscribe, comment. You know the YouTube trifecta. Thank you all so much for watching. I really appreciate you being here with me, and I'll see you next time.